Hi everyone, welcome back to my channel. In today's video, we're going to do formative exercise 4.1, question 1 until question 7. Okay, let's look at number 1. A set of questions contains 5 true or false questions and 5 multiple choice questions, each with 4 choices. What is the number of ways to answer this set of questions? So here, true or false means there are 2 ways, and a multiple choice question each with 4 choices, which means that times 4. So the number of ways for this one, we're going to use the multiplication rule, okay, which is 5 times 2 and then times with 5 times 4, which is 10 times 20, and the number of ways will be 200 ways, and that's the answer. Let's look at question number 2. Find a number of ways to create a 3-digit password for a lock if repetition of digits is allowed and B, repetition of digits is not allowed. Okay, let's solve for A first. Okay, 3-digit password, which means that I'm going to draw 3 lines here. Okay, so if you can repeat the digits, okay, first is you got to think what are the digits that can be used. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here we have 10 digits, which means that for the first place we have 10 ways. Okay, it's from 0 to 9. And then because we can repeat back the same digit for the second place, so the second place, the number of ways is also 10 ways. And then the third digit, the third one, okay, is also 10 ways. So therefore we times them together and the answer is 1000 ways. Okay, now let's solve for B. What if repetition of digits is not allowed? Okay, so first I'm going to draw 3 spaces here. Okay, so for the first place, there will be 10 ways. Okay, which means that from 0 to 9. And then for the second place, because one of the digit has been used for the first place, so therefore left 9 ways for the second place. And then for the third place, so 2 digits have already been used. Therefore, there's only 8 ways left for the third place. Then to find the number of ways, we times them together. So therefore is equals to 720 ways. And that's the answer. How many numbers are there between 5,000 and 6,000 that can be formed from the digits 2, 4, 5, 7, and 8 without repetition of the digits? And how many of these are even numbers? So there are actually 2 questions in this question. So let's solve for the first one first. So we have 2, 4, 5, 7, and 8 without repetition of digits. So to solve this, okay, I'm going to put 4 spaces here because between 5,000 and 6,000, okay, which means that we're going to put 5 in front as the first place, and then this is 1p1 ways. And then here we have how many digits? 1, 2, 3, 4, 5. So we have 5 digits given. So if 1 digit has already been taken for the first place, therefore only left 4 digits for these 3 spaces. So 4p3. And then we times them together. So the number of ways will be 24 ways. Okay, that's the answer for the first question. And then for the second question, so even numbers, it means that the last place must be an even number. So 1, 2, 3, and 4. So the last place can be either 2, 4, or 8, which means that it's 3p1. And then the first digit must be 5, which means it's 1p1 way. And then here will be, so since 2 digits have already been taken for the first and the last place, therefore left only 3 digits. P2 because there are 2 spaces, so 3p2. And then we times them together, okay, and then we'll get 18 ways. And that's the answer. Let's look at question number 4. A couple and their 8 children are going to watch a movie in cinema. Let's say the couple is father and mother, and they have 8 children. So they go together. So total is actually 10 people. So they book a row of seats. So find the number of ways the family can be seated if the couple sits side by side, which means that the father and mother sits together. Okay, so here I'm going to draw 10 spaces because there are 10 members here. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then they say that the father and mother sit side by side, which means that father and mother must be together. Okay, and this is 2 factorial because it can be mother first and then father. Okay, and then the remaining will be for the 8 children. Okay, so total here will be 9 factorial. Okay, so the answer will be 2 factorial times with 9 factorial, which is equals to 725,760 ways. Okay, now let's look at B. Sit at both ends of the row. Okay, so I'm going to draw 10 spaces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and then father sits at one corner and then mother sits at the end. Okay, it can also be mother first and then father. So which means that this one will be 2 factorial ways. Okay, and then here will be 8 factorial. So therefore, okay, the middle, the 8 factorial is for the children, for the 8 children. Okay, so the number of ways will be 8 factorial times with 2 factorial, which is equals to 80,640 ways. Okay, and then as for C, sit separately means it's the opposite of sitting together. So I'm going to use 10P10 for all the members, okay, minus the answer in A. Okay, which means that sit side by side. Okay, and the answer is 10P10 minus 2 factorial times 9 factorial, okay, which is 2,903,040 ways. And that's the answer. Let's look at question number 5. Find the number of ways to arrange each word baku and baka if no repetition is allowed. Are the number of ways the same? Explain. Okay, let's look at baku. So all the letters are different here, B-A-K-U. So therefore, the number of ways will be 4 factorial, which is 24 ways. Whereas for baka, it seems that there's a repetition of the letter A 2 times, which means that the number of ways to arrange baka will be 4 factorial over 2 factorial, which is equals to 12 ways. And then we have to explain to them in the form of a statement. Not the same because the word baka contains identical object, which is the letter A. And that's the answer. Let's look at question number 6. Determine the number of routes for an object to move from point A to point B if the object can only move up or to the right. Okay, so to move from point A to point B, it has to go 5 spaces to the right. 1, 2, 3, 4, and 5. It can also be here 1, 2, 3, 4, and 5. Okay, and so on. So there are actually 5 factorial ways to move from left to right. And then if you want to move upwards, okay, then it will be here 1, 2, 3. Or it can be also here 1, 2, and 3. So there are many ways to go upwards, which means it's 3 factorial ways. Okay, and then total ways, let's say I take one example. Okay, to get from A to B, I use here 1, 2, 3, 4, 5, 6, 7, and 8. So total, there are 8 factorial ways. Okay, so how am I going to do this? So the number of ways, okay, or number of routes, okay, they say number of routes is equals to, so the total must be 8. So you must move 8. Okay, it's either 3 upwards and 5 to the right, or up, then right, then up, right, and so on. Okay, so it'll be 8 factorial over, because there's a repeat of 3 factorial and also 5 factorial. Okay, so it'll be 3 factorial times with 5 factorial, So it's equals to 56 ways. And that's the answer. Let's look at question number 7. A group of 7 children are competing for 6 chairs that are arranged in a circle. The keyword here is a circle. During a musical chair game, the children have to move in anti-clockwise direction around the chairs. Determine the number of arrangements for this game. Okay, so first you see here, children. So children are an identical object and they are moving in a circle, which means that the formula is NPR over R. Okay, so here we have 7 children, which means that N is 7, and then P, there are 6 chairs. So 7P, 6, then over 6, because the R is 6. So equals to, okay, 7P6 is 5040, and then over 6, and the answer is 840 ways. That's the answer.